Hi, welcome to this CorbettMaths video looking at differentiation. Now this is from the level 2 further maths qualification, but it's predominantly for AS level maths, okay? So it's one of the first chapters that you learn in year 12 in A level maths as part of the AS pure mathematics curriculum. Okay, and in this video, I'll be talking through how to do differentiation, okay, and explain all of that in as much detail as possible, okay. But for those of you that can do this, then feel free to obviously pause the video, try these questions, and then press play when you're ready, and let me know in the comments, okay, if it's something that you have covered before, or you've never seen this before, or stuff like that, okay, just so I can gauge the idea and what sort of level I'm looking at. But this is predominantly, okay, for A-level maths, okay. We're going to start with question number 1. I've got the function, okay, or the curve y equals 7x squared. I've got to work out dy by dx. Now, dy by dx means the change of y with respect to x. And the formula for differentiation, so if I have a function y equals x to the power of n, dy by dx, okay, is worked out by doing n times x to the n minus 1. So the power comes down as a multiplier, so it becomes n times x, and then the power comes down by 1, so to the n minus 1. So this is the formula for differentiation, okay. So n is the number, okay, it comes down as a multiplier. So imagine I've got like a 1 here, it's 1 times n, and then it's x to the n minus 1. So if n is 2, then it goes to 2x, okay, essentially. If n is 3, then it goes to 3x squared, okay. The power comes down as a multiplier, and then the power goes down by 1. So using this formula, dy by dx becomes 7 times 2, which is 14, and then the power comes down by 1, so it becomes x to the 1. Now I don't need to actually write that power of 1 there, so it's just 14x, okay, because x to the 1 is just x, okay, so the answer is 14x, okay. So the power comes down as a multiplier, and the power itself decreases by 1. Okay, and that's all we are doing, okay, so we are using and utilizing this formula here. Question number 2, guys. Y is equal to 3x cubed take away 8x. Work out dy by dx. Okay, so differentiating each part separately. 3x cubed, 3 times 3 is 9. Then it becomes x, and the power comes down by 1, so it's 9x squared. This one is a bit more sneaky, okay, imagine it's a 1 there, minus 8x to the 1, so minus 8 times 1 is minus 8, the power comes down, so it's minus x to the 0, but we should know at this level that anything to the power of 0 is just 1, so it's minus 8 times 1, which is just minus 8, okay, so differentiating just x goes to like a constant, okay, something times x goes to like a constant, so it's 9x squared, take away 8, okay. This is question number 3, guys. Y is equal to 8x cubed plus 4x minus 4. Well, differentiating 8x cubed, 8 times 3 is 24. Okay, and then the power comes down by 1, so it's going to be x squared. Differentiating positive x, imagine it's positive 1x to the 1, okay, that just goes to positive 1. And then differentiating a constant in maths just goes to 0, okay, so differentiating negative 4 goes to 0, so the final answer is 24x squared plus 1, or 1 plus 24x squared, okay, either convention is fine, okay. This is question number 4, guys. I've got y is equal to x to the 7 minus 3x to the 6. Work out dy by dx. Well, if I differentiate x to the 7, I get 7x to the 6. The power comes down as a multiplier, and the power comes down by 1. Differentiating minus 3x to the 6 goes to minus 18x to the 5. Okay, so this is going to be 7x to the 6, okay, minus 18x to the 5. Okay, this is question number 5. I've got y is equal to x plus 4 times x plus 2. Work out dy by dx. Well, I'm going to expand this bracket out. So I get y is equal to x squared. Okay, so I'm doing x times x. Okay, then x times positive 2, which is going to be plus 2x. Okay, then I'm doing 4 times x, which is going to be 4x. Okay, and then I'm doing positive 4 times positive 2, which is going to be positive 8. Okay, on this. Okay, now before I differentiate, I'm going to collect like terms and then differentiate. So I get y is equal to x squared plus 6x plus 8. Okay. Now differentiating this, dy by dx, well, x squared goes to 2x, okay, the power comes down as a multiplier, and the power comes down by 1, okay, 6x just goes to 6, and then positive 8 differentiates to 0, so the answer is, dy by dx is 2x plus 6, guys. Okay. Question number 6, guys. I've got the function y is equal to 5x squared, take away 3x plus 7. Find the value of dy by dx when x is 1. So I differentiated and then I substitute in x is 1 into dy by dx, okay? So dy by dx, okay, 5x squared goes to 10x, okay, minus 3x just goes to minus 3, okay, using the differentiation rule. Okay, I now sub in 1 into here, so I get 10 times 1 is 10, take away the 3 is 7. Okay, now this is something a bit more special, guys. When I sub in x equals 1 into dy by dx, it gives me the gradient at that point, okay, and we will come on to that hopefully soon, okay, but this works out the gradient, okay, at a particular point, because dy by dx works out the gradient, okay, of the curve or circle or whatever it is you're looking at, the straight line, okay, or the trig graphs. Okay, it works out the gradient at any given point. Okay, so this one, it's chosen x to be 1 actually, which means that the gradient at x equals 1 is 7, okay, of this function. So when x equals 1, okay, of this function, okay, the gradient at x equals 1 is equal to 7, okay. Question number 7, guys. Y is equal to x cubed bracket x minus 4. Work out dy by dx. Well, expanding that single bracket, I get y is equal to x to the 4. Okay. Subtract 4x cubed. Okay. So differentiating this, guys. Okay. Dy by dx is x to the 4 goes to 4x cubed. Okay. And negative 4x cubed goes to minus 12x squared. Okay, so that's what I get when I differentiate it, guys. Okay, question number 8. Okay, y is equal to 3x minus 2 all squared. Find dy by dx. Well, expanding this bracket, okay, it's a double bracket. So I'm going to have 3x all squared, which is going to be 9x squared. Then I've got negative 2 all squared, which is going to be positive 4, and I've also got like a middle part to my function, okay, 3x times negative 2 is minus 6x, and then times minus 6x by 2 again, I get minus 12x when I expand that bracket. Okay, I appreciate that I've done this obviously in one go, but please do obviously check your answer by expanding that bracket. It's 3x minus 2 times 3x minus 2. Okay, if I now differentiate this, okay, I get 18x take away 12, guys. Okay, when I differentiate this. Okay. Question number 9, y is equal to x to the 9 all over 3 plus x to the 4 over 4. Find dy by dx. Well, again, it's a fraction. Think of it like this, guys, here. Think of it as 1/3 x to the 9 plus 1/4 x to the 4. Now, this is obviously much easier to deal with now, because when you see that, like, it's not immediately obvious what to do, but now I've got a fraction times a power, which is nice and easy. So it's 1/3 times 9, which goes to 3, and then the power comes down by 1, so it's 3x to the 8, okay, plus 1/4 times 4 is just 1, okay, plus 1 lot of x cubed, okay, the power comes down as 1. So the final answer is 3x to the 8 plus x cubed, guys, or x cubed plus 3x to the 8. Okay, either way is fine. Okay. This is question number 10 now. Y is equal to x cubed plus 4x squared plus 2. When x is 2, show that the value of dy by dx is negative 4. Well, differentiating this first, okay, and then subbing in x minus 2. So differentiate first, guys. Okay, I'm going to get 3x squared plus 8x. Okay. Sub in x's minus 2 into here, well, I'm going to get 3 lots of 2 squared. Okay, so just subbing it in and being very careful with it. Okay, I'm putting it in brackets just to make it clear about my substitution. Okay, in case I'm going to enter this into a calculator straight away, okay, and you want to check the answer. Well, negative 2 squared is positive 4, times by 3 is 12, so I've got 12, and then I've got plus, and then 8 times negative 2 is negative 16. So 12 plus minus 16, the plus and minus go to a minus, so it's 12 take away 16, which indeed, in turn, is negative 4. So that is my answer, okay, as shown. Okay, question number 11, guys. I've got y is equal to this, okay. So y equals 1 minus 2x times 3 minus x. Find dy by dx. Well, again, expanding this double bracket, okay, I'm going to have y is equal to 1 times 3 is 3. 1 times negative x is minus x. Negative 2x times 3 is negative 6x, okay, and negative 2x times negative x is positive 2x squared, okay. So sorry that's gone a bit over into the next question, okay. Collecting my like terms, I get y is equal to 3 take away 7x plus 2x squared, okay, so it's a quadratic curve, guys, okay. And it doesn't really matter which order I write it in. Okay, differentiation is still going to follow the same logic. Okay, dy by dx, guys, 3 goes to 0 when I differentiate. Negative 7x goes to negative 7. And then differentiating positive 2x squared goes to positive 4x. So the answer is negative 7 minus 7 plus 4x. Or negative 7 plus 4x, or 4x minus 7. Okay, either way is fine. Okay, question number 12. I've got y equals x to the 4 minus 3 all squared. Work out dy by dx. Well, expanding this double bracket, okay, I get the following. Okay, when I expand, okay, so taking my time here. very carefully. Okay, so expanding this double bracket, we are going to get, okay, x to the 4 times x to the 4 is x to the 8, okay, using the rules of indices, okay, that if it's the same base and I'm timesing, I just add the powers. Okay, x to the 4 times negative 3 is minus 3x to the 4. Okay, minus 3x to the 4. And then minus 3 times minus 3 is positive 9, guys. Okay, collecting my like terms first and then differentiating, I get x to the 8, take away 6x to the 4. Okay, when I collect the x to the 4 terms together, I'm then going to have plus 9. So differentiating this, x to the 8 goes to 8x to the 7. Okay, so it goes to 8x to the 7. Remember that the power comes down as a multiplier and the power comes down by 1. Minus 6x to the 4 goes to minus 24x cubed. Okay, when I simplify that, and then positive 9 just goes to 0. Okay, when I differentiate. Okay, question number 13, guys. Let's just move it all over here. Okay, I've got to write this in index form. So y is equal to 3x to the minus 2. Okay, so that 3 over x squared can be written as 3x to the minus 2. Differentiating this, guys, okay, doesn't matter that I've got a negative power. It's still the same idea. dy by dx, 3 times negative 2 is negative 6. So it's negative 6 x to the minus 3. So negative 6 x to the minus 3 is your final answer. Question number 14. Okay, I've got to differentiate this now, and it's got a division sign, okay, but same idea, same logic here. Okay, so if I expand the bracket on the top, I get y is equal to 3x to the 5 take away 12x to the 4, and that's all being divided by x. Okay, now some of you may panic and think, oh no, I've got a division here. Here it doesn't actually matter because I can divide through by an x. So I can divide everything through by x. So I get y is equal to 3x to the 4, okay, take away 12x cubed, okay, because everything has a factor of x, so dividing top and bottom by x, okay, or x to the power of 1 gets rid of that fraction. Okay, so dividing that by x, I get x to the 4, dividing this by x, I get x cubed there, and then dividing x by x, I just get 1, okay, but there is no need to write over 1. I can just delete that now. Okay, differentiating this, 3x to the 4 goes to 12, okay, x cubed, okay, and then negative 12x cubed goes to negative 36x squared. Okay, question number 15, y is equal to this function, okay, work out dy by dx. Well, if I expand the numerator, I get 4x to the 4, take away 8x squared, all divided by x squared. Well, again, I can divide through everything by x squared, so I get y is equal to 4x squared, take away the 8, okay, dy by dx, 4 times 2 is just 8, so it becomes 8x, okay, the power comes down by 1, and then differentiating negative 8 just goes to 0. Okay, remember that differentiating a constant goes to 0. Question number 16, guys. Y is equal to 9x to the 4 minus 4 over x cubed. Find dy by dx. Well, let's just change it so it's in index form, okay, for the second part. So I get 9x to the 4 minus 4x to the negative 3. Differentiating this, guys, I get 36x cubed plus 12x, and the power comes down by 1. Remember that it becomes a negative 4, okay, because minus 3 take away 1 is negative 4 and not negative 2, okay. Question number 17, differentiate this function. Well, I'm going to have 3/5 times 10, so let's work it out in full. So 3/5 times 10, and then the power comes down by 1, okay, x to the 9. And then this one's going to be 3 times 6, which is going to be 18, x to the 5. Okay, working out the first bit, 3/5 of 10, well, 10 divided by 5 is 2, times by 3 is 6. So it's going to be 6x to the 9 plus 18x to the 5. Okay, so that's my answer for that one, guys. Okay, so hopefully it's making sense so far. Okay, this is the idea of dy by dx, okay, what I call differentiation. Okay, the power comes down as a multiplier, and then the power comes down by 1. Okay, question number 16, y is equal to the square root of x all to the power of 10. Find dy by dx. Well, root x can be written as x to the power of a half. So I'm going to have x to the half all raised to the power of 10. Okay, and using the power law of indices, that if I have a bracket raised to a power, I just multiply the two numbers together, and I keep obviously the power of x in this case. So a half times 10 goes to 5. Find dy by dx. Well, it becomes 5x to the 4. Okay, differentiating x to the 5 becomes 5x to the 4. Okay. So hopefully it's making sense so far. Okay, question number 19. I've got y is equal to this function, which looks a bit trickier. Find dy by dx. Well, if I expand the bracket first and then I differentiate, okay, x to the 3/2 times x to the half, that just becomes x to the 4/2, which is going to be 2. So it's going to be 2x squared there. Okay, and then plus, and then I'm going to do 2x to the 3/2 times x to the 9/2. Well, the 2 at the front stays the same. X to the 3/2 times x to the 9/2. Using the rules of indices, I'm going to add the powers. So 3/2 plus 9/2 is 12/2, which goes to 6. Okay, so it's 2x to the 6. dy by dx goes to 4x plus 12x to the 5. Okay, for that. Question number 20, y is equal to 4x squared plus px, where p is a constant. The value of dy by dx when x is 3, okay, is 5 times the value of dy by dx when x is negative 1. Work out the value of p. Okay, so we need to differentiate this first, okay? And yes, obviously, I don't know what p is, but this is obviously our job to work out what p is. So dy by dx, 4x squared goes to 8x, and px just goes to p. So dy by dx is 8x plus p. Now, it's saying that the value of dy by dx when x is 3 is 5 times bigger, okay, then the value of x, then the value of x equals minus 1 for dy by dx. So I'm going to sub in x is 3 into here first of all, okay, and I'm going to get 24 plus p. Now this is, it's saying that it's 5 times greater, than when I sub in -1 into here. So that's going to be 5 lots of okay, this is 5 times bigger than this. Now, I'm going to be careful here because I don't think it is actually a 5. It goes to a 5th. Okay. Lots of... When I sub in -1 into here, I get -8 plus p. Okay. It's saying that this, okay, is 5 times bigger than this. Hence why I've got a 5th here, okay, because it's 5 times bigger than this. Okay, so if I multiply everything by 5 first, then I'm going to get 120 plus 5p. That has to equal -8 plus p. Okay, subtracting p on both sides, okay, solving the equation, okay, I get 120 plus 4p is equal to -8. Subtracting 120 on both sides, I get 4p is equal to -128, and then dividing through by 4, I'm going to get that p is equal to -128 divided by 4, so half it and then half it again, I get 64, and then I'm going to get 32. Okay, so p is -32. Now let's just check our answer here to make sure that we are actually right. If I just sub this in, okay, 24 plus -32 goes to -8. Okay, is that 5 times bigger than a 5th brackets -8 minus 32, so that's going to be minus, so they end up being equal to each other, so that is true, yes. Okay, so p is equal to -32. Okay. Question number 21, guys. Okay, y is equal to 3x to the 4 plus 8x all over 2x. Work out the possible values of x when divided by dx is equal to 882. So, dividing everything through by the x, okay. So, I'm going to have 3x cubed plus the 8, and this is obviously all divided by 2 here, so I've got to be a bit more careful. I've got a fraction involved, so I can just split this fraction into 3/2 x cubed plus 8 over 2, which is going to equal to 4. Okay, now differentiating this, okay, 3/2 times 3 goes to 9/2. Okay, so 9/2 x squared. Okay, so it's saying work out the possible values of x, okay, so that has to equal to 882. Rearranging this equation to make x the subject, so dividing through by 9/2, same as multiplying by 2 over 9, so I get x squared is equal to 882 times 2/9. Okay, I'm going to do this on my calculator. Okay, so 882 divided by 9 times by 2, so x squared equals 196. Okay, x is equal to plus or minus the square root of it, okay, which is plus or minus 14. Okay, the opposite of squaring is square root. Okay, so x can equal -14 or x can equal +14. Okay, doesn't really matter which one it is. Okay, remember that a quadratic, if x squared equals a number, x equals plus or minus the square root of that number. Okay, so x is equal to plus or minus the square root of 196, okay? And then just obviously be very clear, guys. So I'm rearranging this equation to make x the subject. I divided both sides by 9/2. Dividing by 9 over 2 is the same as multiplying by 2/9. So I multiplied 882 by 2/9. So I did 882 divided by 9 times by 2, and I got 196. And then I've taken the square root of both sides to isolate and get x by itself. Okay, right guys, that's the end of today's video on differentiation. So if this is new to you, okay, then I sincerely hope you found it useful. I hope it makes sense now how to differentiate functions in the form y equals x to the n. Okay, please give this video a like if you found it useful. Okay, subscribe to the channel if you're new, and lastly, turn on post notifications by clicking that bell icon so you don't miss out on further and future videos. Okay, but that's it from me today, guys. Thanks for watching, take care, and I'll see you for the next one. Okay, bye for now.